Hi there, and welcome along to part 2 of our rock, paper, scissors adventure, where we're going to cover the game logic, i.e. determining which player has won. And I've got a couple of other small additions. First of all, we can decide how many rounds to play. And also, I've got it set up that we're actually playing against the computer, although we can easily change that by changing one simple thing in the program, which I'll show you. So this is version 1, this is where we left off in the last video. With one small change, I've removed a set of superfluous brackets on line 14 and line 24 when we're checking whether the player's choice is valid. Now you can always put parentheses around any expression in Python, even if it's something dreadfully simple like 2 plus 2, and it's not going to cause any problems. In a complex expression it can actually improve readability, but in this case there's no need for it, so just to let you know that in case it caused any confusion that the brackets had all of a sudden disappeared. Right, so moving on to the more complicated version. Now, I did record me actually coding this all up, but the video went on towards half an hour, which I thought was asking a bit much of anyone to sit through that. And I did promise my gran that my videos would be 10 minutes or less, and I've already broken that on several occasions. So half an hour would be pushing my luck. Now, I'll talk you through all of the changes here. First of all, we're importing the random module to allow for the computer player. Now, what determines whether we're playing against the computer is line 10 here. So if computer set to true, which it is, then it is a one-player game. So you can easily change that to false if you want it as it was in the previous video. Winning score equals 2 means we're playing best out of 3, and we've got 2 variables to keep score for each player, and obviously they both start at 0. So line 16 to line 24, this is identical. This is player 1 putting in their choice, and we know it's going to be a valid choice. Now line 26 is where we actually test, are we playing against the computer? Now, if not computer means the same thing as if computer equals false, but you'll tend to see if not computer. That's the, dare I say it, more professional way of coding that here. So if not computer, then we would run this code, which again is identical to the previous video where we'd get player 2's choice. Because we are playing against the computer though, we just run this else block, and I hope this is straightforward. We just get a random selection from rock, paper or scissors and assign that as player 2's choice. So moving on to the meat of the video here. Now I've actually coded 3 different versions and I'll quickly talk through them. Now that's 3 of dozens, if not more, possible different versions. There's a huge number of different ways you could do this. And it's interesting to know, even for a relatively simple program, there's a huge number of ways of doing it. So if you've come up with something different, then it may well be better than any of these versions here. So if you want to post your own ideas of how to do the logic, then I'd be interested in seeing that. Now, the first version I've got coded here uses nested ifs. Now, that just means we've got a conditional inside a conditional. Now, I'm not going to go through every line here because I think that me, as well as you, would probably get a headache by the end of it, but I'll just talk through the highlights briefly, and obviously you can ask any questions. Now, one thing I was aware of is that 3 of the 9 possible combinations result in a tie. That's obviously rock, rock, paper, paper, and scissors, scissors. So it made sense to me to test for a tie up front, and I've actually done that in all 3 versions here. So that's what we do first. So given that it's not a tie, we then move on to cover the 2 other scenarios where player 1's chosen rock. So we only actually have to do 1 explicit test. So I chose to do rock plays paper. Could have just as easily done rock plays scissors, but I did rock plays paper, and then that meant paper covers rock, player 2 wins, add 1 to player 2 score. Now, I could have done another explicit test to check whether player 2 choice was scissors, but given that we've covered the other 2 possibilities, that is the only other scenario. So whilst doing another explicit test would arguably make the code more readable, it does make the program less efficient. Although, to be completely honest with you, a program with this simplicity, you could obviously run this on a 40-year-old ZX Spectrum and it wouldn't bat an eyelid, but good to be aware. It's an idea at least to know the most efficient way of doing things, even if you don't necessarily code it that way. So I hope that makes sense. So like I say, I'm not going to go through every line, but similarly, if we come down here, rather than saying if P1 choice equals scissors, I've just done an else, because the code above covers P1 choice being either rock or paper. So again, scissors is the only other game in town, so that's why that is an else block here. So what I think I'll do, let me just run the program. I think I'll just run it once so that we're not here for the end of time. Oops, I've just gone into the Python shell for no good reason at all. So let me run the program here. So I think I called it rps2.py. Right, so I'm just going to choose rock constantly here. So player 2 chose scissors, so we won that round here. And that one's a tie. And so maybe getting a lot of rocks here, but we must have won that one as well. Yep, so final score, player 1 2, player 2 is 0. So that's one thing actually I haven't shown you. Just the very last line of the program, we print out the final score there. That's fine. And also the whole program is wrapped in this while loop here. So while player 1 score is less than winning score and player 2 is less than winning score, so the whole of the rest of the program will keep looping apart from obviously this last line, which is outside of the loop, but everything else will loop whilst line 16 is true. Okay, right. So what I'm going to do now is I'm going to comment out this nested if version, and let me uncomment this second version here. Now the difference with this version is we're using logical AND. So again, I'll not go through every line of code. So we do the check for a tie, same as before. We then go through player 1 choosing rock and player 2 choosing paper, and then we do player 1 choosing rock and player 2 choosing scissors, and then we've got player 1 paper, paper, and scissors, rock. And again, we've got a final else here because we obviously get to the stage where all other conditions have been covered. So let me just run the program again. Just want to make sure obviously that all of these versions work properly. And we do actually have a problem here. Line 68 68. Let's see what we've got here on line 68. So this should still be commented out. Let me try that again. Right, so this time let's just keep choosing paper continuously. So we've got a tie and scissors cut paper, so we lost that one and we lost again. Never mind, we'll get over it. So that's that version here. So it's kind of individual choice. I mean, we could have been even more verbose and done even not covering all of the conditions that result in a tie. We could have literally went through all 9 possible combinations, and as I said, that would make the code more readable. You might get repetitive strain injury typing it out apart from everything else, but it's not too bad. I mean, 9 combinations isn't ridiculous. That's why rock paper scissors is quite a good program to use, because it's complex enough to be interesting, arguably, but not overboard. It doesn't get crazy. Right, so let's comment out this one, and let's uncomment, should be 3 not 4. Let's uncomment this. Now this is the most succinct. Now there's a couple of things here I want to explain. What I've basically done is after covering the tie as the same as the previous versions, I've done a check which covers all of the scenarios that result in a player 1 win, and then done a final else, because obviously if it's not a tie and it's not a player 1 win, then it has to be a player 2 win. So that's why we can do that final else. Now, these backslashes at the end of lines 96 and 97, if you haven't seen these, I know I haven't mentioned them in the course so far, these are a line continuation character. We have seen backslashes as part of escape sequences to, for example, do \n for a new line within a string, but here we're using it slightly differently, and it just makes the code more readable. I could have easily just put that all on line 96, we would have been scrolling along to the right to see it, so I thought I would use the line continuation character there. So again, just to go through it, so we've got player 1 chooses rock and player 2 chooses scissors, or player 1 paper, player 2 rock, or player 1 scissors, player 2 paper. If any one of those conditions is true, then player 1 wins. Else, again, probably labouring this point now, if it's not a tie and it's not a player 1 win, all we're left with is a player 2 win. So there we go. So again, to comment that line out there, oops. And let's just make sure that we have a working version here as well. Let me just make a little bit of space. And this time I'll just keep choosing scissors, assuming I can spell it. God, I hope they don't keep choosing scissors as well. Oh God. Right, so what happened there? Scissors cuts paper. Now one thing to note is we're not getting the scissors cuts paper and what have you, which makes the game slightly less descriptive, but we have explained the rules up top, so just need to settle for that. Right, so there we go, we lost that one, or we won that one. Oh, roller coaster of emotions there. Okay, so that's that. So rock, paper, scissors is done and dusted. As always, I'll put a link with the code that you can get down below in the comments there. So like I say, let me know if you have a better or even just a different way of doing things. and I hope to see you in the next lesson. Thanks a lot now. Bye bye.